Hello and greetings to everyone. Today we are going to look at some useful signs and notations in mathematics. We know mathematics is a language. Some useful signs and notations in mathematics. You know that in mathematics we make so much use of signs and notations. It is very important to have a good mastery of the signs and notations used in mathematics. Someone who does not have a good mastery of the signs and notations used in mathematics will face a lot of difficulties in studying mathematics. Now let's take down the various signs and notations used in mathematics. The first one, we have the plus sign. Plus sign, or the addition sign. For example, if we take 2 plus 2, it gives us 4. You can see we are making use of another sign here, which is known as the equal to sign. We go to 2, we have the minus sign, or the subtraction sign. For example, if we take 10 minus 8 is equal to 2. We go to 3. For 3, we have the multiplication sign. For example, if we take 5 times negative 2 is equal to negative 10. 4, we have the division sign. Division sign. Take, for example, 200 divided by 2. The answer is 100. Equal to 5. We have the equal to sign, the equality sign. We make use of this sign when two things are the same, or two quantities. For example, negative 5 is equal to negative 3 minus 2. Go to 6, we have not equal to sign. This side looks like. We make use of this when two quantities are not the same. For example, 8 is not equal to negative 8. 7, we have the greater than sign. We make use of this sign when comparing two numbers, which one is greater than the other. For example, 21 is greater than 15. Go to 8, we have the less than sign. For example, negative 20 is less than 0. We go to 9. 9, we have the greater than or equal to sign. Greater than or equal to. For example, we can see 3 is greater than or equal to 2. We go to 10, we have the less than or equal to sign. Less than or equal to. For example, you can see 0 is less than or equal to 1. We go to 11. 11, we have a plus or minus. And we make use of plus or minus in problems where we have to add or we have to subtract. For example, if you take 7 plus or minus 4, simply means you're going to take 7 plus 4 for the first solution, which gives us 11, or we take 7 minus 4 for the second solution, which gives us 3. We go to 12. For 12, we have the approximation sign, which stands for approximately. equal to. For example, we can say 1 is approximately equal to 1.2. Move to the next. We have a sign for congruent to. Congruent to. For example, we can say triangle ABC. You can see we are making use of this symbol. It stands for triangle ABC is congruent to triangle PQR. Move to the next 14. We have an arrow as such pointing to the right. We call it the implication sign. We make use of this sign when we are to draw conclusions. For example, if we take this problem 4x is equal to 5, then we can draw a conclusion by saying x will be equal to 5/4. We go to the next 15. We have an arrow pointing at the left hand side and at the right hand side. We call this one the equivalent or if and only if sign. We make use of this symbol when from the formula we have at the left hand side, we can derive the formula at the right hand side. And from the formula at the right hand side, we can derive the formula at the left hand side. For example, we take a raised to the power x is equal to b if and only if the log of b base a is equal to x. You see, from what we have at the left hand side, we can derive what we have at the right hand side. And from what we have at the right hand side, we can go back to what we have at the left hand side. That's why it has two arrows. We go to 16. We have symbol looks like an 8 which is sleeping. We call it the infinity sign. It stands for infinity. It stands for very, very, very large numbers. Very large. We go to 17. We have pi. We know this is a constant, and it is simply the ratio of the circumference of a circle to the diameter of that circle. So for any circle, for you to get pi, you simply divide the circumference of that circle by the diameter of that circle. It is always the same for any circle, and it is approximately 22/7. It is a constant. You can verify. We go to 18. We have this symbol such which stands for angle, for an angle. For example, we can say angle ABC. That means the angle at the vertex B of a triangle with vertices ABC. That's what it means. We go to 19. We have a small O which hangs up like this, and it stands for degrees, which is a unit for measuring angles. For example, 30 degrees, 45 degrees. We go to the next 20. We have the rads, which stands for radians. And this is a higher unit for measuring angles. For example, we can say pi/4 rads, which is the same as 45 degrees. We go to 21. 21 we have two lines meeting like this. For this case, for this we say the two lines are perpendicular. Two perpendicular lines. For example, we can see the line L1 is perpendicular to the line L2. You can see we make use of the symbol. We go to 22. Make use of this other symbol for two parallel lines. Two parallel lines. For example, we can see the line L1 is parallel to the line L2. 23. We make use of this symbol for triangle. It stands for a triangle. For example, we can see triangle ABC. That means a triangle with vertices ABC. We go to 24. We have verse with these ones. We have parentheses. We make so much use of this under arithmetic. Parentheses. Especially in problems where we have to make good use of board mass. We go to the next. We have square brackets. Square brackets. The square brackets are bigger brackets to the parentheses. We make use of it in problems where we have to apply board mass. And we use the square brackets to include parentheses. 26. We have braces. We call this one the braces or curly brackets. These are bigger brackets to the square brackets and the parentheses. We make use of curly brackets to include the elements of a set. Next, we have this symbol which stands for an element of or belongs to. For example, no one belongs to the set of natural numbers. We go to 28. We have this other symbol which stands for is not an element of. It's not an element of or does not belongs to. For example, we know 0.5 does not belong to the set of integers. We go to 29. We have this symbol which looks like a C, very sharp. It stands for a subset of. For example, the set of natural numbers is a subset of the set of integers. We go to 30. We have symbol which looks like a C as such, pointing in the opposite direction, which stands for contains the set. For example, the set of integers contains the set of natural numbers. We go to 31. We have this other symbol which is mostly used to denote the universal set. Universal set. That means a set that contains all the other sets. We go to 32. We have U as such, which stands for the union. We go to 33, we have an N, which stands for the intersection of sets. That means common elements that you can see in those sets. We go to 34, we have an N as such, or you might see it in some books like this, which stands for the set of natural numbers. And this set has first element 0. We go to 35, we have N star. It is simply the set of natural numbers excluding 0. Set of natural numbers without 0. The next, we go to 36. We have Z as such, which stands for the set of integers. It's the set of natural numbers and their negative counterparts. We go to 37. We have Z minus, which stands for the set of negative integers. It's the set of negative whole numbers. We go to 38. We have a Z plus such, which stands for the set of positive whole numbers. The same as the set of positive integers. We go to 39. 39 we have cure, which is as such, and it stands for the set of rational numbers. When we talk of rational numbers, that means numbers that can be expressed as a Volga fraction. We go to 40. We have Q to the power C as such, which stands for the set of irrational numbers. These are numbers that cannot be expressed as a fraction. We go to 41. We have R such, which stands for the set of real numbers. When we talk of the set of real numbers, it is simply the union of the set of natural numbers, the set of integers, the set of rational numbers, and the set of irrational numbers. We go to 42. We have C as such, which stands for the set of complex numbers. When we talk of complex numbers, these are numbers that have real and imaginary parts. We go to 43. If you see a number, for example, a number x in between two bars as such, it stands for the magnitude of that number x, which is always positive. The magnitude of x. We go to 44. We have this symbol, which looks like such. It stands for the summation sign. This stands for summation. We mostly make use of this symbol when we sum the terms of a sequence. The next one, we go to 45. The symbol looks like an S as such. It is known as the integral sign. We make use of this under integration. That means when we calculate the area under a curve, we make use of this sign. We go to 44. We have this one, which is the square root sign. For example, we can take the square root of the number 4, the square root of the number 9. We go to 45. We have it almost looks like the square root sign. At this Vn, we have an n. It stands for the n root. N root sign. For example, when n is equal to 3, we are going to talk of the cube root. For example, the cube root of 8. When n is 4, we are going to talk of the fourth root. For example, the fourth root of 16. When n is 5, we talk of the fifth root. 6, the sixth root. 7, the seventh root, and so on. We go to 46. We have this other symbol. It looks like a V with a horizontal line on it. It stands for all, which is the same as for every. We go to 47. We have this other symbol which looks like an E, capital E facing the left. As such, it stands for there exists. 48. We have 3 dots as such, which are arranged triangularly. It stands for therefore. Go to 49. We have 3 dots as such, still arranged triangularly this way, which stands for because. Next, we go to 50. We have 2 dots as such. We make use of these 2 dots under ratios when we compare 2 quantities. It stands for a ratio. For example, we can say a ratio of boys to girls in a particular class is 5:9. Go to 51. We have 3 dots as such. These 3 dots, they stand for and so on. We make use of these 3 dots when you are listing an infinite set. That means a set which does not have a last element. We go to 52. We have IE, notation IE, which stands for that is. We go to 53. We have EG, which stands for example given. These are some of the basic signs and notations we will be making use of in mathematics. It is very important to have a good mastery of the following signs and notations. Please, if you like the video, you share and do well to subscribe to this YouTube channel. Thank you very much for watching.